So in this section, we're going to discuss differentials and tangent lines. First thing, let's define what we mean by a tangent line. So by the textbook, we have that the tangent line, y equals L of x, to the curve, f of x, at a given point, is the straight line that passes through that point and has the same slope as the curve. In other words, we have that L of x, so this is the y coordinate of our line, minus f of a, the y point on the line, is equal to, well, this is the slope of our curve, so it's going to have the same slope as our curve, x minus a. This is just the point slope form, or we could rewrite it and say that the line is equal to the slope of the curve times x minus a plus f of a. This is the standard form of the tangent line. So if we take an example, we can compute, say, the tangent line to the curve, say, y equals f of x, which will be, say, 1/2 x squared minus 2x plus 7/2. So this is our curve. It's a parabola. And we want to know what is the equation of the tangent line. So at a given point. So let's say at the point 1, 2. So at the point 1, comma 2. So at that point, we need to figure out what is the slope of this curve, and then we would have our form. Y of x, or L of x would be the slope times x minus 1 plus 2. So really the only work we have to do is find out what the slope is. And I'm just going to work it out in general instead of at a point. So we know the slope is the standard part of the change in y over change in x. So we will let delta x be an infinitesimal. Then the change in y is f of x plus delta x minus f of x, which is, scoot this over, which is 1/2 x plus delta x, quantity squared, minus 2 times x plus delta x, plus 7/2. So that's the f of x plus delta x, and then minus f of x, which is 1/2 x squared minus 2x plus 7/2. And if I expand this out, I'm going to need much more room. So if I expand this out, I will get that this is equal to 1/2 x squared plus x delta x plus 1/2 delta x squared minus 2x minus 2 delta x plus 7/2, and then minus 1/2 x squared plus 2x minus 7/2. And so this 7/2 and this 7/2 cancel, this 2x and this 2x cancel, this minus 1/2 x squared and 1/2 squared x cancel. And so now I've got together an x delta x, 1/2 delta x squared, and a minus 2 delta x. So I'll rewrite it as this, x minus 2 delta x plus 1/2 delta x squared. So there's our change in y. And now to compute f prime, remember f prime is simply the slope of change in y over change in x. So f prime of x is the standard part of change in y over change in x, which is the standard part, x minus 2 delta x plus 1/2 delta x squared, all divided by delta x. And now we've got delta x's everywhere, so they cancel. So this is the standard part of x minus 2 plus 1/2 delta x. Now x and 2, those are real numbers, and delta x times 1/2 is an infinitesimal, so I get left behind that f prime is equal to x minus 2. Great. So we know our derivative function. Let's remember what we're doing here. We want to know the tangent line to our equation 1/2 x squared minus 2x plus 7/2 at the point 1, 2. And so we will plug 1 into our derivative, and here's our equation, right? L of x is equal to f prime of a times x minus a plus f of a. So here we have that a is equal to 1. That's our point. So at the point 1, 2, the tangent line is given by L of x is equal to f prime of 1 times x minus 1 plus f of 1, which we know is 2. And f prime of 1, well, f prime is x minus 2. Right? This is our f prime. We've calculated that. So we get a minus 1 times x minus 1 plus 2. So this is our tangent line at that point, negative x minus 1 plus f of 2. So let's open up a graph and look at how this all works out. So here is the graph of 1/2 x squared minus 2x plus 7/2. And we're looking here at the point 1, 2. That's the point where we calculated the tangent line. And if I plot the tangent line, it slices through right like that. And so we can see that it just kisses the graph and then ricochets off. And we'll talk a lot more about the tangent line and its application and interpretation later on. But a feature I want to take a close look at is something we talked about last time, and that this tangent line locally is very much like the curve. They have the same slope, and when we get really close to 1, 2, then we will see that the line agrees, kind of get this more centered, the line agrees with the curve. The red is our curve, our parabola. The blue line is the tangent. And so very close, they agree very much, but there is some differences. And so I want to talk again about the comparison of the slope of our tangent line and really our rough estimate of the slope of our curve. So we could talk about the change in y. So change in y, we say we go over a certain amount of units. In this case, we're going to go over 0.2 units. So definitely not an infinitesimal anymore. If there's an infinitesimal, we'd be on the line. But this is a pretty small number. We're going over 0.2. And then we would go down to reach the line. Whoops, we may have to do better here. Sorry, just getting things centered. So the change in y, so if I go over x, the change in y and how far I would go down to hit the curve would be f of 1 plus delta x minus f of 1, which we know, as we calculated earlier, is negative delta x plus 1/2 delta x squared. So that's how much we truly would go down if we make a change in x of, in our case, 0.2, but any change of x would satisfy this equation. Now for the curve, for the tangent line in blue, we also have a slope. And we can talk about the change in the line. So again, if we go over delta x from the line, so we go over, and then if we go up to hit the curve, That's our change in L, which, because this graph has a slope of -1, if I go over x in the positive direction, I'm going to have to go down negative x in the y direction. Again, this is because our change in y over change in x is -1. And so notice here that the negative delta x and the negative delta x here appear in the same place, and that's actually not a coincidence. In our next video, we'll work out abstractly that there is a relationship between this change in the line and the change in our curve itself, and that the difference is just an infinitesimal. That'll wait till the next episode.